Welcome to CML InfoTech. Today, the second session from CCNA talking about the introductory or basic concept. So we'll do a small recap of the previous session. Okay, we were discussed about two-tier network architecture. When you have a network design, all your edge system like PC, okay, one of the network architecture design says you need access switch and you need core switch. It's a simple network design. All your edge devices, such as your PC or camera or workstation, ACS, access controls, anything you will be connected to the ACS, access switch. Then the access switch will connect it to your core switch. We have an in-depth session to talking about the usage of core switch, the usage of access switch, and how we can define and design. Two-tier എന്ന് വെച്ച് കഴിഞ്ഞാൽ just ഇത് മാത്രം, core access. Then we have a three-tier, then we have four-tier. We will discuss later about this. Then the one of the major discussion about networking called LAN, local area network, and wide area network. When we talk about local area network, we have a network devices like example switch. Your edge device can connect via cable. This is, we call it as a local area network, which means this local area network can be within the room, within the building, within the campus. Example, you have building 1 and you have a building 2. You have a system here connected to a switch. To connect between building 1 and building 2, nowadays we're going to say copper cable, which is UTP, and we're going to say fiber cable. If you have a copper cable, this should not go above 90 meters. Copper cable എപ്പോഴും 90 meters അകത്തായിരിക്കണം. അപ്പോൾ lengthiest distance interconnect ചെയ്യാൻ വേണ്ടി we always recommend it to go with the fiber cable. So ഇത് ഒരു building, ഇത് അടുത്ത building. So there are it is long distance, but still we can pull the cable and connect between them. Then we also call this as LAN. In reality, when we talk about this connections in the office, you will have servers. Example, recording server. And you have camera. This camera need to be recorded in your recording server. That is the requirement. Let's say this camera may be outdoor camera or indoor camera. This camera in the 3rd floor. In the 3rd floor building or in the 3rd floor, you have a room. This room we call it as IDF. And in this room, you will have rack where you can mount your switch. And here I mounted switch. This switch we call it as access switch. Depends upon the camera, let's say fiber or copper, we can use a type of switch, maybe fiber switch or maybe copper switch. But the ACS, or we call it as ASW, access switch, means your camera connected on that switch. So let's say the camera cable will come to your IDF and will connect it to your patch panel. So this is called patch panel. From the patch panel, we will use a small patch cord to connect it to your switch. This is camera 1. Same thing when you have a camera 2, cam 2, will connect it to your patch panel. And from the patch panel, we'll connect it to switch. Let's say you have a 24 port switch, you can connect 24 camera. Now, you have a server, which is again in one specific room. This room, we call it as MDF or data center. And within the data center or within the MDF, you will have a rack. We call this as a rack. They may have one rack or more than one rack, depends upon the equipments or availability or the requirement. And within this rack, we will mount our server. Let's say this is recording server 1. Again, every rack will have patch panel. So let's say this rack will have patch panel 2, let's say P2, patch panel 2, and patch panel 1. Patch panel 1. Now, this server will connect it to a switch. So let's say I have another rack, rack 2, and here I have switch. The server will connect it to this switch, and this switch we call it as core switch. The server, either via directly pulling the cable or via patch panel, we will connect it, our server, into a core switch. So in shortly, the camera connected to the access switch and the server connected to core switch. Depends on what module that we have, like fiber or copper. If it's a copper, we will pull the copper cable. So from the camera towards to the access switch shouldn't be cross 90 meters, and same as on this side. Now, we need to interconnect from my core switch to the access switch. So again, they are in a different place. Maybe this is in the ground floor or on the basement, and this is in a different building or different floor within the building. Wherever the camera is required will be placed. Now, every rack will have a patch panel, either fiber patch panel or we will have copper patch panel. Now we need to connect from core switch to the access switch. Always between switch to switch, we always recommended to connect with the fiber connection. Okay, so now we will pull the fiber cable from the fiber patch panel from R2 will goes to the fiber patch panel of IDF. So between MDF and the IDF, there will be a splicing. We call it as a splicing. Fiber splicing. Then we will use a small patch cord from fiber patch panel to the core switch, and from the fiber patch panel of IDF to the access switch. So we are explaining about the local area network. Do not think always that if directly connected with the shortest length will be considered as a LAN. No. By using a fiber cable, we can pull the cable with the lengthiest distance. We also consider it as local area network. So you have a server here, which is a recording server, and you have camera here. You need to make them a network. Maybe you have two camera 2, camera 1. This camera feeding needs to be recorded in the recording server. That is our requirement. We have a many methodology to implement this design with a 2-tier, 3-tier, 4-tier network architecture. We can go with the simplest one. The server will connect it to the core switch. This is the 2-tier design. And the camera will be connected to the access switch. ASW, access switch. We'll connect it here. Now I need to connect between core switch to access switch. Let's say this core switch located in MDF room. This access switch is located in IDF room. Or in other way, the access switch, the room where the access switch is located, we call it as IDF. The room where the core switch and the related servers, firewall will be located, considered as an MDF. Core switch ulla sthalathe MDF ennum, access switch located in the room IDF ennum vilikkum. Now we need to connect in between them. So generally, the core switch will be located in a specific rack. We call that as a rack. So for example, I'm going to make the name as MDF R1. This is the rack name. And here, this is the name of the rack, IDF rack 2. When you define a name for any device, any rack, any room, there is a legend. You need to follow the same legend. Either we need to create by ourselves, or the end customer are already following a specific legend that we need to know. Now we need to connect in between them. As I said, always between switch to switch, we go with the fiber connectivity, the best solution. Now you have to understand that there is a patch panel on top of the rack, which will have a splicing, and that is connected in between rack to rack. We call it as 12 core or 6 core, 12 core, 24 core splicing. Okay, and we will use a fiber patch code from, let's say if I'm connecting from This is correlates 1, 2, fiber splicing. If I'm using from here, will connect it to my core switch. And the other side of the same cable will use to my access switch. Okay, so this is the idea behind the reality, how we will be connecting our core switch to access switch or between any switch to any switch. There are a few more concepts that we need to be clear before we going to connect. So let's say when you use a fiber connectivity, there are two. One, we call it as LR. The other one, we call it as a SR. Again, in the switch, there is a slot. Let me show you the switch. CX. When you connect between a switch with the fiber connectivity, we have to have, call it as SFP. And this will have a speed called 1 gig, 10 gig. When you have example access switch, so let's say I'm going to explain in a general way. When you have an access switch, example 24 ports access switch, the 24 ports, which is for downlink. So keep in mind, there are two, downlink and uplink. The downlink will be utilized to connect the edge device, and the uplink will be used to connect it to another switch. And if my switch downlink, example 1 gig speed, then my uplink must be 10 gig. And there should be 10 gig. Always switch to switch interconnection must be higher speed than the edge device connection. And if you have a 24 ports copper switch, which means you have 24 ports, 1 gig are copper connection, UTP cable. And your uplink would be fiber connectivity, which we gonna say that SFP connection. Then, when I say SFP connection, there are two, LR and SR. SR for the short range, LR for the long range. Example, your access switch and your core switch, or your minimum 2 switch located in the same rack, like you have a 1 switch here. And if you're planning to connect between these 2 switch, which are in the same rack, we can go with the SR. Or your 2 switches are of farthest or a long distance, then you can go for LR. This SR and this LR is the SFP, which the connector will be used in the switch. Then you also need patch code, fiber patch code. This SR and LR, we're going to say that SFP, example SFP 10 gig. LR or SFP 10 gig SR. The 10 gig represent that your speed of the SFP. SFP is nothing but a connector which will be used in the switch to connect between them. If you are using SR, then your patch code will be multi-mode. Multi-mode patch code. If your SFP is SR, then your patch code must be single mode. So what is the difference between them? Just think about if you have a 2 device, 2 switch, you're connecting near each other. Maybe they are in the same room or in the same rack. Then you're going to use multi-mode with the SR SFP. Let's say your one switch in one building and your another switch in another building, and you want to make them as a interconnection. Because of the longest distance, you can go with a single mode patch code, a single mode connectivity with a SRSFP. If you are using multi-mode patch code, then your backbone connectivity must be multi-mode. If you are patch code, you're going to use a single mode, then your backbone connectivity must be single mode. So let's say I'm going to show you the switch. See catalogs. Share. Can you see my screen? Cisco products catalog. So let's say product catalog. I'm going to show you the switch. The Catalyst series. We'll explain what's the difference between Catalyst and Nexus, all this in our upcoming session. Let's say example 9300. Series switch. Can you see the front end of the switch? Hope you can see my screen. This is, so let's say, yeah, here you can see. You can see this Catalyst 9300 series of 24 port switch, which means here you can see that port number 1, port number 2, then you can see until port number 24. 24 port switch. Here it shows that 24 port switch. Then again, we can see that network module 10x, 10 Mbps. So 10 GB, or 10,000. But here you can see this is a copper module. So here you have 24 ports downlink and 4 ports uplink, which is 10 gig uplink. But again, this is a copper module. So we'll look into some other switch. So let's say we'll go back and look into the switch. Example 5000 series. 5670. Here we can see a module. This is, we call it as fiber module. Here we will be inserting SFPs to get the speed. Here you can see the port number start from 1 until port number 48. This is called fiber module. We can insert the fiber slot of fiber SFP in this specific switch. We can see, is there any other module or other switch? Let's say Catalyst MV series. Catalyst series. Here we can see this, the model of the switches. Catalyst 3750 Cisco switch. Here you can see that console port, of course, this is for configuring the switch. We'll come across in the future. And you can see this. We are trying to understand about the downlink and uplink in shortly. So here you can see that port number 1, and you can see the down port number 2, then up 3, then the down 4, then the up 5. Like this, it will go until the last port 23 and 24. So these 24 ports called downlink to connect your edge device. Then you can see here 2 ports, which are uplink. Then you can see the port, it looks different than your downlink. The downlink is a copper, which you can connect your UTP cable. And then your uplink is a fiber, which is connecting with the SFP. When we say SFP, it's a connector we will be used to connect to the fiber connection. This is one of the model of the switch. And here you can see the back side. We'll talk about stacking later. This is the power slot. That's it. Then we will see as an example of some other simple switch. Okay. Here you can see catalyst 65 9,000 series. Let me filter with the 9400. 9400. 9400. Yes. This is one of the other type of switch. Here you can see modules. You can see here that 1, 2, this is called module. Module 1, module 2, module 3, 4, 5, 6, 7. Total 7 module. And in all this module, we can see that gigabit Ethernet switch. It's a copper switch module up to 48 ports. So here you can see 48. Then again, you have a second module. If your requirement is larger, like you have 100 systems to be connected or more than that, then you can also propose the modular switches. And 9400, 94 series is one of the module. Then you can also see here the fiber module. So the difference which you can see here, the top one, module 1 and module 2 are copper, and the module 3 and module 4, which you can see fiber. So when you have a copper and fiber, just remember that the fiber always be recommended to connect to another switch. So this 9400 switch, maybe we're going to use as our access switch to connect our camera or any edge devices. Then this 9400 access switch must need to connect it to your core switch via copper connectivity. And why do we have a 2 module? For redundancy. Let's say you have a 2 core switch. One core switch will connect it to your module 3, and the second core switch will connect it to module 4. Don't worry, we will come across with this. So the idea behind to show this is that you can have multiple copper connection in one switch. Then you can propose with your modular models. So here you can see on the back side. Back side, and this is the front side. And you have a power supply, by the way. Let me show you about the SFP as well. Here you can see that SFP. You can see this SFP is the fiber, and hereafter you can see also SFP with the copper. We have a copper SFP and we have a fiber SFP both. This SFP, you will get SR or LR. The SR for the short range with the multi-mode cable, and LR is for long range with a single mode cable. So when you have this SFP with you, you need to insert this SFP into the switch, which means We can see here the switch module. So the SFP module that you will be used to connect into the SFP module in the switch. Any doubts? Okay, so this is all about the basic idea about LAN. So when we say LAN, we can use any model of the switch. Only the concern that your cable must be reach each other, either via fiber or via copper. Then your LAN network will be success. Okay. Fine. So we will continue our session day after tomorrow, Friday or Saturday. I'll give you some homework just to make sure about the previous session. And 2 or 3 session more, most likely about theory. Then we will start our lab. Lab and theory mixed together. Okay, so hope you understand the session today. We will continue by the next session. Thank you. Have a good time from CML InfoTech.
Thank you very much.
Okay, bye. Bye. Thank you.